Alright guys, welcome to the 20th tutorial of LibGDX, and as you can see again, we are going to create a very basic car in Box2D today. So we want to get rid of Luigi and whatever he's doing there and replace this with a nice little car that we can actually drive. So yeah, we don't need any of this anymore, so let's just delete all the work that we've done in the previous episodes. Actually, oh, not all of it. We want to keep the ground. So just this. Yeah, and we don't need to catch the ground body actually. We can just create it. And we don't need any of this. And this. So let's just get rid of it. Okay, then we also don't need any of this stuff here and the sprite, and we also don't need this poster sprite. Also, we don't need the key up method in the listener, and most of the stuff in this one. We still want to be able to go back to the level menu, but that's it. There are still arrows right here. We don't want to do this, and to this I'm gonna get later, so let's just comment this out. Of course it's not working anymore, and yeah, so like I said, we want to get a car. Let's actually create a car right there. So this class doesn't exist yet, obviously, so we have to create it. Okay, we're gonna create our car here. Car, great. But we need to create the car class actually, so let's go ahead and create the class car. In the entities package that doesn't exist for you yet, and it's gonna actually do nothing. Alright, so what does a car have? At first, the car has a few bodies, that is the chassis, the left wheel, and the right wheel. Also, a car has two kind of connections, which are the axes. So, left axis and right axis. Just for your information already, these are going to be joints, but there is a special kind of joint that fits our needs perfectly, which is called wheel joint. So we can just set this as wheel joint immediately. Then let's go ahead and create the constructor. So what's this car going to take in its constructor? At first, the world, because we need to call the world.createBody and create joint methods. So we need the world. Also, we have a bunch of opportunities that we can use to make this happen, but let's stay flexible and actually just take the fixture definition of the chassis and the fixture definition of the wheels. So we get their physical properties. The shape is going to be set inside this constructor here, but we can get their physical properties from outside, so we can create all kind of cars. Also, let's get their X and their Y position, and their width and height. So this should be enough to create all kinds of cars. Alright, so what is this? Okay. At first, let's just go ahead, pretty normal, and create the body definition. Body def equals new body def, and we don't need to create fixture defs because we have them in the argument list up there, actually parameter list. So, alright, at first we want to create the chassis. For this, we are going to use a polygon shape, because the chassis is not a circle and not a simple box, but even for a simple box we'd use a polygon shape. But anyway, chassis shape equals new polygon shape. So it can have all kinds of yeah, shapes. Alright, chassis shape, and this time we are not going to use set as box because there's not going to be a bus or something. It's actually going to be individual car. So there are two ways to do this. At first we have set, which takes a float array of vertices, or set, which takes a vector2 array of vertices. It totally doesn't matter which one we are going to use, but I'm just going to use the one that takes a float array, just to confuse you a little bit, and because it is shorter. We don't have to write so much. So how is this going to work, you think? This .set method actually wants to take the vertices of this polygon shape, actually of this polygon. So a float is not like a vector2, an x and a y value, it's just one value, but that's a pretty simple solution there. It's just going to take the numbers we pass in there in the following order. It's going to expect the first one to be x, then y, actually x1, y1, x2, y2, x3, y3, and so on. So yeah, that's pretty simple. Alright, so the first vertice of the chassis, we are going to define them in counterclockwise order. Okay, they need to be in counterclockwise order. Otherwise, I don't know if it's going to work, and I don't want to try this right now. So, in counterclockwise order, let's begin with the bottom left. This is going to be on the x-axis at width divided by 2, because the center point is 0. We just want to take the half width divided by 2. And yeah, that's it. Then for the y value is going to be height divided by 2. Pretty simple. The bottom right of the car is going to be also pretty simple. Width divided by 2 and minus height divided by 2. The top right of the car is going to be a little bit more to the left than the bottom right, and yeah, actually at the top. So let's say width divided by 2 times .8f, so it's just not this much to the right. Actually, let's say 7.5, and height divided by 2, because now it's going up, no minus there. Yeah, that's it, height divided by height divided by 2. Now the last vertex is the top left corner, which is at minus width divided by 2. But let's make it a little bit more realistic, so times .8f, and not so high, so let's say height divided by 2 .8f as well. I have no idea how this is going to look. Maybe we'll copy it from my test. Alright, so there are the vertices. Doesn't really look very, I don't know, good, but this is the way that it's done. Alright, so we are now going to take the chassis fixture definition and set the shape to the chassis shape. We are not going to touch the rest because we are going to set the density and restitution and whatnot outside of this class, so we can create all kinds of cars. Yeah. What does the car need as well? That's actually it. World dot, oh yeah, we want to set this as the chassis body. So what is Eclipse automatically doing? Chassis equals world dot create body definition, and of course chassis dot create fixture chassis fixture definition. Yep, that's it. Now we can go for the left wheel. The left wheel is going to move independently of from the actual chassis, because it can go up and down a little bit, like how it's hanging on the axis and stuff like that. It can also rotate, of course, because it's a wheel, so it needs a a body that is independent from the chassis. At first, let's create the shape again, which is gonna be a circle shape. Wheel, damn it, wheel shape equals new circle. I cannot type. Circle shape. Woo, did it. We are just gonna set the radius of it to height divided by 2.5f. So it's a little bit higher. The radius is a little bit bigger than half of the car. Seems pretty realistic to me, and I tested it like this, so it's working. That's it for the wheel, for the circle shape actually. We are just going to do what? Yeah, we are going to take the wheel fixture definition and just set the shape again, because the other physical properties are set outside of the class. So let's say the shape is the wheel shape. Then we can already go ahead and create it again. Left wheel equals what does it equal? Now I lost myself. Left wheel equals world dot create body definition. Yeah, awesome. Then left wheel dot create fixture wheel fixture def. So the body def was not touched since the chassis, because it's no difference, it's still just a dynamic body, which we actually have to set up here. I'm sorry. Body def dot type equals body type dot dynamic body. So it's the same for both. The chassis is a dynamic body and the left wheel is a dynamic body, and we didn't change anything on the body definition here. So we also don't have to change anything here, because they are all the same for the body part. But of course the fixture definition is a different one. Alright, let's go for the right wheel. And this is actually having the right shape. We can take a lot of the wheel of the left wheel from this one. So the right wheel has the same shape. We can just go ahead and create it immediately. Right wheel equals world dot create body definition, and right wheel dot create fixture wheel fixture definition. It's the exact same as the left wheel, just another position. The positions are going to be set using the joints that are going to be the axis, so we don't have to take care of that right now, and just create the stuff. So how does this look already? Pretty not so good, I guess. Let's go and check it out. If we are we can just see if we are lucky, and chassis actually looks good. Okay. Of course we have to go into the play screen and actually create this car, otherwise that's not really making any sense. So car equals new car, and this is taken the world, the fixture def, the wheel fixture definition, 0 on X, and let's say 3 on Y, so it falls down a little bit and we can see how it's responding to anything. It's gonna be 3 meters wide and 1.5 meters high. This 1.5 is just for the chassis, okay? So don't think it's too low. If I imagine a car that's 1.5 meters high, it seems pretty low, but it's just the chassis height. The wheel height is not included. So we need another fixture definition here. Actually, we can put it right there. The wheel fixture definition, which is also equal to a new fixture definition. Now we can go ahead and set the physical properties of the car. So let's say at first the physical properties for the chassis. Fixture definition dot density equals 5, just because it's 5, okay, whatever. fixture definition dot friction. Let's say that's .4. I'm just taking them from I don't know where. And restitution equals yeah, car doesn't really have much restitution, so these values should be fine. And for the wheel, fixture definition dot density, we wanna go fixture def dot density minus dot 5f. And okay, dude, I'm not really available right now, or whatever. And wheel fixture definition dot friction equals well, since these are the wheels, they should have a high friction, so let's actually go ahead and set this to 1. And wheel fixture definition dot restitution equals .4f, because they're a little bit bouncy, just how wheels are. So now we should be able to see our car, and there it is. That is a really great car, isn't it? At first I think the wheels are a little bit too big, and of course everything is having totally crap positions and everything, and not sticking together because the axes are still missing, and also the chassis is looking a little bit weird. So let's just take the top right point, so this is y of the last point, x of the last point, this is the y point that we need right now, and this is the x point that we need. Yeah, the chassis is looking better, but let's actually reduce it down a little bit more. Just .4. Yeah, this looks a little bit better like a chassis. And the wheels are still very big. The wheels, so the wheels are actually still pretty big, so where do we do that? Set radius, right, probably divide by 2 again, because this is the radius and not the whole diameter. Alright, so okay, those are pretty small wheels, but we'll take care of that later. Yeah, I said we are going to take care of that later. No, I'm doing it immediately. Anyway, I think this was the value that worked out pretty well. Actually, this was the value. Yeah, this looks good. So let's go ahead and create the actual axis, because how it is right now is not really oh, we forgot one thing. You see that the car immediately falls down because it was created at 0, 0, which is under the ground, but we actually are taking the x and y position in the constructor, so it makes sense to set those right here to the body definition dot position. So we are going to call set and give it x and y. Alright, that should be all for the fix, and there we go. The car doesn't fall down anymore. We can actually set its position. Of course the wheel position is now also set, but like I said, who cares? They are going to be taken into the correct position by the axis joints. Alright, left axis. This is going to be, like I said, a wheel joint. Here we can see it again, a wheel joint. So we are going to create a wheel joint definition called axis definition equals new wheel joint definition. Axis definition dot body A is going to be the chassis, because the wheels have to be connected to the car. Axis def dot body B is gonna be left wheel. That kind of makes sense. That's not all we need. We can set a bunch of stuff, and we definitely have to. At first, let's take not care of anything and see what happens. How about that? We are just going to say the left axis equals world.create joint axis definition. And we have to cast this to a wheel joint because create joint returns a joint, but the left axis is a wheel joint. Alright, so let's go ahead, and we see they are already connected, but the wheel is staying right on the chassis. And in case you didn't know, by default, if two things are connected to each other with a joint, they have collisions with each other disabled. So this ball is actually this wheel is not colliding with the car right now, and that's actually good, because for our simulation this is just what it's going to look like. But we could also go ahead and say axis definition dot collide connected equals true, and they would be colliding with each other constantly. This also works for any other kind of joint definition, so you can do this on whatever, but we don't want this. Anyway, as we can see, they are set at 0, 0 and 0, 0 with the local anchors, but we want the local anchor of yeah, we can actually choose this. We want the local anchor of body A, which is the chassis, to be down here. Let me zoom in a little bit. To be down here, so the car has the left wheel at a proper position. To do this, we are just going to say axis definition dot local anchor A equals yeah, not equals, but set. And now we have to think a little bit. Minus width divided by 2.75f times 0.75f, and y is gonna be minus height divided by 2 again. Alright, I think this is going to look better. And yeah, it already looks a little bit like the car is having the wheel at the correct position, but we still want it a bit more to the right, in my opinion. Let's actually say we want to move it this far to the right, how big the radius of the wheel is, because the position there is good, but the wheel is so big that it goes over the left side. So we're just going to subtract the radius of the wheel, so it's going to be aligned correctly. So we go right here to the x value and say minus wheel shape dot get radius. Let's see if this is going to work. Oh, actually not minus but plus, because we are moving from the center point of this body. And yeah, that already looks like a better position in my opinion. Okay, so let's go ahead and create the axis on the right side. Right axis. We can use the same wheel joint definition as well. So axis definition dot body B equals right wheel, because we still want body A to be the chassis. We don't have to set it again. And axis definition dot local anchor A dot set. No, actually not. We can actually do a little trick and say x times equals -1. So it's gonna be just on the opposite side, seen from the position of the body. And oops, we still have to create it. Right axis equals world dot create joint axis definition cast to a wheel joint. And there we go. There are wheels on this. But as you could just see, actually, yeah, I have to start it again. Did you see this? The car, the wheel goes to the right, but the axis in my car at least, they're not going to the right or the left side. They're actually staying and just moving upwards or downwards and not left and right. So how can we fix this? This is something special of the wheel joint definition. So the wheel joint definition, actually, let's see here. The wheel joint definition allows rotation about around this point, and is something like a prismatic joint, which we haven't talked about yet. But a prismatic joint is like a spring. So this is like a spring right here, which we can actually rotate freely. Right now the spring is rotated on the x-axis, so it's going to this direction. But we want it to go around the y-axis, so it's going this direction. And to do this, we can just say axis definition dot local axis A. There is no local axis B, so I don't know why they put this A there. Probably to yeah, say it's actually the axis of the local anchor A. But anyway, we can set it to vector2 dot y. We could also just take the y value. We could also just say 0, 1. This would be the exact same thing, but I like to take vector2.y because it shows just its y. We can see here again, it's just a new vector2, 0 and 1, which is static, so we are not really creating anything new, and we can clearly see it's moving on the y-axis. So I like to just use this method. There we go, and we see they are already moving on the y-axis and not on the x-axis anymore. But what kind of axis is that can't even hold the car? And not really, I don't know, useful to drive on. So let's go ahead and at first move this point here down a little bit, so they have more room, more space to rotate and do whatever wheels do there. This is the line where we set the local anchor A of the left axis of the axis definition. So let's just go into its y value and subtract some more, like actually say times this divided by 2 times 1.25 or something. And we can already see these points are more are lower than they were before. But still, the car cannot really hold itself. It's almost hanging to the ground, and that's not good. So to fix this, we can go ahead and say axis definition, and there's a bunch of stuff here. For example, where is it? Frequency hertz. I don't know how to pronounce this, but these are actually the hardness of this axis. So just for instance, I could set them to 100 and this car would go crazy. Oh, it's not even going this crazy, but I could set them to 100, and as you can see, it can definitely hold itself properly. But it's also a kind of boring car because it's looking like fixed. There is no nothing softened or anything. Actually, if we set it to 5, it's gonna be looking just fine. Did you see that? How it's falling down and bouncing up again? Yeah, that's what a car is looking like. So why this 5 value? 5 is because in the play screen we set the density of the chassis to 5. So it makes sense to set this to 5 as well, because it can hold exactly that density in a proper way. So let's actually go ahead and say chassis fixture definition dot density, and that's it. Working fine. Right. So thanks for watching, and in the next tutorial we are actually going to talk about how to get this car to move, because right now we have a car but it cannot drive. Alright, see you then.